Hi everyone, now we are going to learn about the light emission spectrums of hydrogen atom. What is actually the light emission spectrum of hydrogen atom? We know that in order to produce the photon emissions, here, the hydrogen atom will have a transitions of electrons from higher orbit of higher energy level to lower energy level. So we have learned, basically we have learned in details about 3 levels, which is Lyman series, and then followed by the Balmer series, and then followed by the Pascal series. So according to this series, these 3 series, this one has the highest energy. And then followed by this one, the energy is followed by Balmer series, so this one is in between Lyman and Pascal. Well, this one has the lowest energy of photon produced by this series, Pascal series. So if we look at this diagram, so this emission is the photon emissions through the hydrogen atom, so it will form the diffraction pattern at here. So this one is your diffraction pattern. Okay, so this one is the centra. Centra will have m equals 0, and then this one is your first maxima, m equal to 1. So in order to form first maxima, so this one is your angle theta, so you will have the equations for diffractions for constructive interference for the first maxima. Okay, for constructive interference we have d sine theta equal to m lambda, then for first maxima is m equal to 1, so you will have d sine theta equal to lambda. In other words, the first theta is the smallest angle. So for smallest angle, which is your first maxima, so because angle is directly proportional to lambda, so in order for lambda becomes the smallest one, so theta becomes the smallest one, lambda must also be the smallest one. In other words, when we have the smallest lambda or the shortest wavelength, so energy is the biggest one, is the highest energy level. So in other words, we have let's say we have 3 series, Lyman, Balmer, and Pascal. So the one that form first maxima, on first maxima is Lyman series. So the Lyman series will form first. Okay, it will produce the diffraction pattern where it starts from centra and then Lyman series, and then continue with Balmer series, and continue with Pascal series, and so on. And then of course for the lower part here, so still m equal to 1, it starts with Lyman series nearest to the centra, and then we have Balmer, and then we have Pascal. Is it clear? Okay, this is how your diffraction pattern form on the screen, where we have the maximum energy which is nearer to the centra. So when it goes further away from centra, the energy will decreasing. Energy decreasing and also decreasing. Lambda will be increasing. Okay, when it goes further from the centra, so this one is your centra, m equals 0. So E decreasing, F decreasing, lambda increasing. Is it okay? So if you not really understand, so we look at this first. So for Lyman series and Balmer series and Pascal series, it will form like this. So this one is actually your centra. So m equals 0, this one is centra. So the one nearest to the centra is Lyman series. Why? Because you know that because d sine theta is equal to m lambda. In order to have theta which is very small, lambda must be very small. When lambda small means E also is big. So means that the one which has a smaller diffraction angle is the highest energy of photon produced. So this one we will start with the Lyman series, Balmer series, and Pascal series. In other words, when you go across away from the centra, there is an increasing in wavelength, decreasing in energy, and decreasing in frequency. So if you look carefully here, so this one is the one nearest to the central bar is actually transitions from the n equal to 6 or n further away from the nucleus to ground state. Okay, so for Lyman series, if you look at this one, and Lyman series, if you look at this Lyman series, for Lyman series, this one is the highest energy in Lyman series. This one will be the lowest energy in Lyman series. Okay. While for Balmer series, the first line of your Balmer series from here is from the highest energy in Balmer series, and the lowest energy of Balmer series is from on the last part of your Balmer series spectrums here. Okay, of course, in Balmer series, the higher energy here is actually lower. It's lower than the lowest energy is Lyman series. The energy at here, let's say this one is energy at L, and this one is energy at B, is always greater than energy in B. Okay, your Lyman series always can have greater energy in Balmer series. So of course, for Pascal series, the first line of the Pascal series is actually the highest energy level or highest photon that emits higher energy photons that emit through your Pascal series, and then the last one will be the lowest energy. Okay, is it clear? So this is how you interpret the line spectrums of hydrogen atom. So you just have to remember that the one nearest to the centra has the highest energy. When it goes further from the centra, the energy will be decreasing. So if for the Lyman series line spectrum, the one nearest to the centra will have higher energy level in Lyman series, and then this one, okay, this one will have higher, for Lyman series, the one nearest to the central will have highest energy of photon line, and then this one will be the lowest energy in Lyman series. It will follow by Balmer series. So for Balmer series, this one it will start with the highest energy and then continue until the lowest energy, and then it will go to Pascal series, which has highest energy and then followed by lowest energy, and then followed by the bracket series, and then fun series, and then etc. Okay, so that's it for your line emissions of hydrogen atom. I hope you can understand what I tried to explain. So thank you.